Everyone, welcome to this DataFlex Technology Stack live stream. My name is Jolanda Smit and I work at the Creative and Marketing Department here at Data Access Europe. And later today I will also be joined by Harm Wibier. And Harm is the lead developer of DataFlex, so he knows everything about DataFlex. And then also who will join is Bram Nijenkamp, and he built the new runtime that will be discussed in the presentations about Technology Stack. So if you have any questions about Technology Stack and what you're about to see, these guys are the guys that will give you all the answers. And we're not doing this alone today because during these live streams, we're teaming up with our channel partners. And today we would like to welcome Dennis from Data Access North America. Welcome, Dennis.
Hi, Yolanda. Hi, everyone.
Hello. I would like to ask you to introduce the rest of the live stream.
Great. Welcome, everyone, again. We're going to see two pre-recorded presentations from EDUC 2024 today, talking about the technology stack, one by Harm and one by Bram. Please ask your questions in the YouTube chat. Some of them will be answered right in the chat as you're asking them, and some of them will be answered afterward in the live Q&A. They will also always, from all of our live streams, be available on DataFlex-dev later. If you don't see the chat, please refresh your browser, and let's start the first presentation.
This presentation, I'm going to be talking about tech stack. And this presentation has been split into two different parts. So first, I'm going to talk a little about what it is for those that might not know already, and kind of more of the business side, what you can expect, and those kinds of things. And then Harm, tomorrow at the very last presentation, I believe, he will be doing the more technical side and show some nice demos and such. In other words, I'll be the one promising you that this is all going to be released in December of some unknown year, and then Harm will do the trust me it works vibe, and then that all comes together. So let's get started. Tech stack. Let's see if All right, I'm going to introduce you to Bob. This is Bob the repairman, and Bob has the needs to be done job in the sewers, where he has to hold up an administration of all the pipes that might need maintenance and those kinds of jobs that you can imagine. And he has to do this on paper currently, and then when he gets back to the servers, he has to put them in an Excel sheet or anything like that. So very tedious work. Now, what you can imagine is that this job would be much easier for Bob, and if he could do this on his phone and then just get an internet connection and sync it up to a cloud somewhere or anything like that. The problem that you can imagine is that, of course, in these sewers, poor Bob doesn't have an internet connection. Now, what Bob really would need, however, of course, is an app that temporarily stores these changes on the device, and then only when he gets back up to the servers and has an internet connection, then syncs those changes up to the cloud. And we've heard this story more than once before, both maybe even from one of you guys. And then the question is, well, how can I build an app or web app with DataFlex that runs on device as well on my mobile phone? And then the unfortunate thing that we have to tell you guys is that, well, we can't really do that yet. And that's what this presentation is about. So let's take a look at what DataFlex web apps are right now. So a DataFlex app right now is something that would be as what we would call server heavy, meaning that every time that you do a button click, scroll through a web list or click on a row, it will go to the server and ask, oh, what do I need to do with this interaction here, right? So every single click going to the server. And in the case of Bob, what Bob really needs is what we would call a fat client. And this means that all the business logic, every click on a button, is first processed on device. And then only when your program determines that it needs to fetch some data, store it on a server somewhere, only then will it call to the server and say, here I have some data, go do with it what you want. And this seems very comparable to other languages, which you might already be more familiar with, and that brings me to technology stacks. So if we were to now, of course, start an entirely new web application, right? So a full stack application, we can generally need to choose some languages that we want to use for this application. And these are some modern ones right here, and I've separated them into 4 different categories. Of course, we can think of more, but to keep it a little bit simple, we have a front end containing our user interface. We have a back end, so for our server-side logic, and then if we all agree, store it in our database. And then we also have this 4th category being a mobile application, or a mobile app as we call it these days. So if we were to choose one of all these languages, for example this one, we have of course our HTML and CSS for our user interface. And then we choose one of the many of thousands of different JavaScript frameworks like React, Angular, Vue.js, the ones that Nick called out as well. And in this case, we're going for Angular. Then, of course, we build our application there, but then the application needs to store some data, and that's where we're going to need a server or a backend that's going to process our requests. And you can choose from many, so for example, Node.js, Python in this case, to keep it a little bit simple. We don't have that many demands here, but of course, Java, C#, and even DataFlex for REST APIs is possible as well. And then, of course, the databases are known to us. We'll just go with SQL Server. And then it gets a bit complicated, because on mobile, if you want the best experience, you will have to build an app for every single platform that you want to support. Now, I think most of us here have either an Android phone or an iOS phone. And if you want to do a native app for that, then you have 2 different tool chains altogether. So if you want to build for Android, you will need to use Android Studio, which means that you will be building a Java application in most cases. And then for iOS, you'll use Xcode with Swift. Now, there are some go-betweens, like for example Xamarin, but also React Native is an option where you will share a code base, and the compiler will try to build your application on those different platforms with the same style and such, but it will never be completely native, so to say. Now, you might be wondering, well, where does DataFlex fit in here? So DataFlex, up until now, has had the unique position to share one code base, and it would cover both the front end, so the user interface, as well as your back end. Of course, the databases are still known to us, but if we wanted an app, we would have to, scratch DataFlex and start all over with something different altogether. And that's what we want to do with the DataFlex new technology stack. So we want to bring the option of DataFlex to those mobile applications as well. So how are we going to get there? Let's take a little look at the requirements. So the first, of course, is to make sure that every button click or any other interactives are processed on device instead of continuously going to the server. What do I need to do with this? So that means also that, of course, we'd like to put our app in the App Store or the Play Store for that matter, so that we can download and install it on device. It should be able to run without an internet connection and only go to the server when we want to. And it should have DataFlex DNA, which I will get back to later. So what was our idea here? So, of course, we have had the DataFlex runtime for a while now, and up until now, the DataFlex runtime has been running on Windows only. And what we intended to do was to bring this runtime to your browser, meaning that your DataFlex code, which you guys are building, will run in the runtime, but within the browser locally on your own device. And, we did consider some other examples here. Of course, we could have built one of the thousands of JavaScript frameworks that are out there, since, well, that seems to have worked out for them. But that wasn't good enough, because we wanted to keep our DataFlex DNA. And what does that DataFlex DNA mean? Well, one is uniformity, meaning that, of course, we want you to only have one language to learn, which is, of course, DataFlex. And only if you want to do some more advanced stuff, you can get into the HTML, CSS, and JavaScript, but, you would be able to build a full application with just DataFlex. We have a very unique UI-driven object notation, which of course many of you have been completely accustomed to, but is very rare in other programming languages. Because in DataFlex, we simply nest some objects, and with such nesting, we create our user interfaces. Very unique here. We have, of course, data-aware controls. Entry item command is the only thing you need, and every control will automatically save, load, and store data in your databases. Of course, our business rules, using our data dictionaries, ensuring validity as well as security for our data. And of course, that everything is out of the box, meaning in this case that, I have one studio and I click and run my application with the click of a button. And of course, all the unmentioned features which make DataFlex that easy to deploy your applications. So to get this Windows runtime running in the browser, just how are we planning to do that? We are going to use WebAssembly for this. And WebAssembly is a technology from 2017 and is since, or has been since, coming more and more into production environments. For example, Blazor from Microsoft, which is also a WebAssembly product. And it runs in all the major browsers that you might know. So for example, Firefox, Chrome, Edge, all the major ones. I don't think they're or I certainly hope not many of you will be using Internet Explorer anytime anymore. Yeah, and WebAssembly is a format or an instruction format that is much smaller and also precompiled, which allows it much more performance than, for example, JavaScript. And it enabled us to compile our DataFlex runtime to WebAssembly, allowing it to run in that browser. So a runtime that works in a browser, and of course you guys will then be providing a DataFlex application which will allow the browser or the runtime in the browser to run. And as such, the runtime will only go to the server only when you specify to do so. So it's entirely up to you at that point. That means that we now have two different backends. So it's a different paradigm than we have been used to up until now, because now we have both a web app server as well as something that we would call a web app client. So where does it differ? Now we have the web app client containing all the UI logic, the business logic for local verification, and then going to the server when it needs to save data. The web server will take that request and then use its own same version of the business logic to verify it for itself because of security reasons, of course. And in essence, the web app server will then only expose data dictionaries to, process those data requests. And of course, any REST APIs or web services that you might need to accompany it with. Which brings me to the DataFlex tech stack. Now, as you can imagine, of course, this whole project of porting the runtime to WebAssembly did not go as easy as we might have hoped. And there's a good reason for that, and that's because in 1995, DataFlex became Windows only. And there was a good reason for that because, of course, as well, both your businesses as well as others moved to Windows deployments as well, and as such, we followed those as well. But that also does mean that as we went to Windows only, our Unix versions and those kinds of code bases went unmaintained for, well, over 20 years by now. And then next to the fact that, of course, the entire code base itself is already 40 years old as well. So, porting the code base to WebAssembly, well, then went as great as you can imagine. So in total, it would seem, well, to be a hard investment to, try to get this 40-year-old code base all the way to WebAssembly. And that's why 3 years ago, we decided to do it entirely from scratch. So that means that we started from zero and started to just, bit by bit, build this entirely new runtime with a new code base, C++ and all the stuff, which is a very, very big project. And it has touched every single part of the DataFlex ecosystem with many components entirely rebuilt from scratch, like the runtime, the data API, and for example, the expression compiler. But also, of course, the compiler, debugger, and studio having needed to be updated as well, some entirely new components with new debugger backends, and also the package manager, which I will get into tomorrow. Now, as you might imagine by now, is that this is no longer just about that mobile app support. Because there's also this wish list which you have been providing us over the years, containing items like, you know, WebSockets, Flex data dictionaries, DLLs, microservices, cross-platform, asynchronous function, and all the likes. You know, it has become quite hard to give you these features as fast as we would like, and we hope that with this new runtime we can, you know, give you these features sooner, as you would have been able on the current code base. Now, you might be wondering, well, what is going to happen to the code that I have been writing for 40 years now? So DataFlex will remain DataFlex with its own DataFlex DNA, and that means that we do not intend to do a complete redesign of the language, doing something completely different. So that means that, you know, we want to keep things as migratable as possible, allowing you to have your current web app, well, you know, soon up to be compatible with a WebAssembly version or something that you can deploy on a mobile phone. However, of course, as you can imagine, with all these changes, there will need to be some, well, more rather drastic changes to be ready for the next 30 years of DataFlex as well, which brings me to portability, which is the main reason for this. So now we have a new web app or a new server-side runtime, as well as the WebAssembly one, but we also intend to bring DataFlex back, like in the old days, all the way to Unix, macOS, and Linux as well, besides, of course, Windows and WebAssembly. And that means that APIs that you guys have been using for, well, almost 20 years now, which completely depend on Windows, needed to become platform agnostic again. And that means that some concepts, classes, needed to change with that as well and have been rewritten into, well, either a new class form, which is platform agnostic, or became a new concept altogether. So, for example, the CHTTP transfer class, which depends on Windows sockets, now has been renamed to the CHTTP client, which works now on all those different platforms of the above. And for example, COM, which is a completely Windows concept, now has become something different entirely, being the external classes, which I believe Harm will take a little look at tomorrow as well. So what was our plan? When and what can you expect from us? Now, because of the scope of this, well, quite enormous project, we have separated everything into 3 different phases. So phase 1 mainly focuses on bringing this new DataFlex runtime to the WebAssembly side, which allows, since it's now completely offline, will also allow you to have more responsive web UIs, because for every click it doesn't need to go to the server, which might be somewhere in Wisconsin or something. So, you know, much more responsive web UIs. And besides that, phase 1 will also at least allow you to have your web applications wrapped inside of a mobile app, which you can deploy to the App Store or anything like that. Now, one thing of note here is that we are still looking as to how much we can automate from within the studio, as especially the iOS platform is quite a bother to automate the building of an app here. And then lastly, this phase 1 will provide us with 2 different runtimes here. So one that you use for the backend, so the web app server, and then we have the new web app client as well, which runs on WebAssembly. Yeah, and of course with these new runtimes for both WebAssembly and Windows, you now get some nice styles that you can consider when you're building an entirely new app. So while it's a little bit harder, you can use the tech stacks on both sides, so both on the server as well as the client, allowing you to have the latest APIs and, well, possible best integration for a full stack DataFlex application. You can also mix it around a bit, meaning that you could have, if you wanted, for example, the web application framework on the client with a different REST service, like for example Python or anything like that, you'd be able to do that as well. Then, of course, you know, you can also still keep the more simple paradigm that we are accustomed to now. So with the button click going to the server, but still with the latest technology by using the tech stack server on the runtime, or the tech stack runtime on the server with no client. Of course, we are going to support the current runtime for a whole long while as well, so that will remain an option. as well. And then lastly, you can of course also combine the current runtime with a tech stack client runtime, but that will just leave you with REST services in this case. And, you know, all these different styles will allow you to compete better and better with other businesses using other tool chains, like for example Angular and the likes. But still with the ease of DataFlex, and now with the new runtimes allowing for much more customizability as well. Then we have phase 2, and we're going to stick with the web servers here because with phase 2, of course, up until now, or phase 1 has focused on the Windows runtime as well as the WebAssembly runtime. And then in phase 2, we are going to look at the other platforms as well, of course, including macOS, Linux, and those kinds of platforms. And this will include a new web app server, which you can deploy on Linux or any other platform that you might want, allowing for a more diverse hosting option, for example, NGIX or anything like that, that you can host the DataFlex app behind at that point. And then also allow it to run as a container in, for example, a Kubernetes cloud. And which will, of course, allow you for more scalability of your applications to take much more load, as well as those, well, you know, to detach a little bit more from Windows IIS if you want to, which can be cheaper, especially with these Amazon costs these days, you know. Phase 3, I have to admit, is mostly unplanned, but of course, phase 1 and phase 2 have been focusing more and more on the web app stuff, and then in phase 3, we want to take a step back and make the new runtime focus more on general purpose applications, which means that we'll also come back to running, for example, a user interface local or on your local machine, like you have been accustomed to with the Windows framework. And of course, you know, not forgetting all the new technologies that this new runtime will bring. And do not forget the wishlist items. Now, when can you expect this? As of course you will today not miss out on is DataFlex 25, which is still to be released, which will contain some great new studio tooling and other features. But after that, the package manager, as well as this whole tech stack project, is the single most focus point for us. And as such is intended to be the full next release after 25. Well, so what are we waiting for? How far are we? Of course, Harm is going to show you tomorrow, but as you'll see, a whole lot works. But there is some, you know, some difficult or more difficult things, like for example, data APIs, because up until now we have had direct connections to, for example, a SQL server or anything like that. But now with the runtime in the browser, we of course can do that, and as such there will be some, you know, change to that, which you'll obviously see tomorrow. And of course, you know, the whole studio work is still left to do, so we want to make it as easy for you as possible to, you know, create these new applications as well. And like I said, we still have got that to look into that whole mobile automation stuff too. With the click of a button, build your app. But we hope to bring you a technical preview soon, or as soon as possible, after 25. Now, a valid question here: what is going to happen to the current DataFlex runtime? We are going to support it for a whole long while, which of course you have been, or what we have been known for as well. And this new runtime will only slowly take over these multiple different platforms. But even after these 3 phases are finished, you can expect a whole long time for support for these, well, current runtime, as we would call it now. With, of course, features, bug fixes, and all the likes included, with even some backports that already have been planned. So all in all, I think the future looks bright, and, you know, to take the quote of the day, I think that it will bring your applications to new horizons. That was my presentation.
Okay, so that was the first presentation of Bram. And I believe that there were some questions in the chat. So Dennis, can you please pass the first question?
Yes, would the client software, would the client-side runtime allow function keys to be used again?
Yeah, so I guess presuming that we're talking about the on-key command, I guess, right?
Yeah,
At least that's the way that I would read it. At least
it will work using the key handlers that we currently already have on the web, using the add key handler.
Yeah.
And so basically, it'll be the web control, so it will also be the web way of handling keys. So that's what's going to be there, I guess. So that's
Okay.
Yeah.
Okay. Another question.
What will the model for Flextron applications look like? Presumably, it still requires a DataFlex client to run the EXE, but the newer runtime will be running within the local hosts?
That's an interesting question as well. It's there's actually multiple ways we could do this, and it's actually funny because when we started the tech stack project, we were actually thinking of needing it for Flextron as well, and then later we thought it through and we found out that we didn't need tech stack for Flextron, so we did Flextron without tech stack. But of course, we're going to do Flextron on tech stack, and what I think we'll do then is because the power of Flextron is that you can access local APIs, printers, files, things like that. That you want to run, Flextron natively, or you want to run the new runtime natively on Windows, and then have it open a browser environment, and then talk to the user interface. The way Flextron currently does, using the current paradigm pretty much. So what the classic runtime is doing right now. I think that would make most sense.
It's also probably the most efficient.
Yes,
so
also
you have
the
two
most
runtimes.
Yeah. Also, you would have two runtimes within the same application talking to each other. So that's likely the way it would work. And but that would be limited to have pretty much only the full Flextron way.
Right.
So you would basically have that would allow you to build full Flextron applications and not mix Windows with web controls, because we don't have the Windows controls on the new runtime. So that's. Does that answer the question? I think so.
I think so. Yeah.
Surely.
Yeah.
Are there more, Dennis?
Yeah, I'm going to go to one that's a little bit related. It's how about the studio? Will that be web-based or Windows-based? Or Windows only?
Harm loves that question.
Well,
do you?
Yeah, well, it's actually funny that for a while now I've been advocating that the studio will one day become a full web app, and that doesn't mean it has to be cloud-based, because of course with Flextron you can run web technologies locally. So we do have a long-term vision of the studio being built with web controls, and with Flextron it could still run locally, but that also means that it would run on the web. And an example of that is actually we're always looking at other stuff, but one of the projects we have going on is that we have been looking at replacing the editor, and for that we are looking at a web-based editor, so that will be a small step in that direction. So whenever we design something new for the studio, we are looking at having the goal in mind of one day the studio
should be web-based, at least
being web-based, but it's going to be a slow process, and it's not going to be something that we will have overnight. It's
no,
but one day I think the studio will become a web app.
Okay, sounds good. More questions.
Okay, how is this going to be secure? How does the server know if it's actually a DataFlex application?
Yes, that's a good question. So if we're talking about web app clients, which I'm going to now use, then I guess, just like when you currently build a web app server, you can never really trust a client, right? So it can be JavaScript, so the web app framework that you're talking to. You could also be mimicking HTTP requests through Postman or anything like that. And as such, you can never really trust a client. So the server can never be assured of the fact that it's talking to one of these web app clients. And as such, just using a session key, needing to log in, these kinds of things. So you use existing technologies or security procedures to actually make your application secure. And it goes for the data interaction as well. Now, as far as the web app client is concerned, it also doesn't necessarily, like in the presentation, it doesn't necessarily require talking to a web app server. You can also be talking to like a Python API or something from your government or pretty much anything. So it's not necessarily required to work with a web app server, but it is recommended, so to speak. So
So what you're basically saying is that the server-side APIs that this new WebAssembly client is going to talk to need to be secured the same way as any other web service, or so there will be like an access token or something like that, an authentication system on that. And of course, the web clients, JavaScript frameworks, for example, can't be trusted in that sense. So that's also what we're doing with the web framework, that everything that comes back to the server, we always
Need to
assume
verify
that it can be changed on the client. And the same will go for the WebAssembly environment. That's also, we should treat that it's running in the JavaScript environment, so it's a similar thing. The only thing is that, of course, it will be a little more difficult for bad willing to do stuff with it, because it's comparable to how Windows works. You have this FLX with binary data in there, which makes it a little more difficult. But of course, in the end, it's still an untrusted client. That's
exactly.
Okay, clear. More questions?
Last question is, what's the ETA for these
Of
phases?
course. The
Of course,
ETA.
there's always an ETA.
Yeah.
Yes, that's the thing we're not going to talk about.
Yes, exactly. Yeah. We do not have an ETA. You can expect something similar to what we had with DataFlex 20.0, where we first had some technical previews to actually showcase, and because of course we're building an entire new runtime, so you can expect many bugs and many missing features and all these kinds of things. So what we're working towards right now is a technical preview to bring you as soon as possible, of course, and then we can kind of estimate how far we actually are, because of course you guys might pop in missing features that were in the old runtime or in the current runtime, and all these kinds of things. So that's the ETA that you're gonna get.
Yeah.
Yes, it's going to be a long release cycle, and we're working towards a technology preview that will already allow you guys to build stuff, and hopefully maybe also usable stuff, and at the same time we will be improving it. So that's we hope to deliver something soon, but
Onto the technology preview then.
Yes.
And then we're going to the next presentation, because we have to dive into the technology of technology stack, and that is the presentation from Harm. So let's go to that presentation.
Are we still hanging in there? Sure? All right. So who wants to hear a little more about that technology stack project that Bram was talking about yesterday? I need more hands. Yeah? All right, good. All right. So let's go. I'm going to do a chronological walkthrough a little bit. So there will be some similarities to what Bram already said, but my teacher always used to say repetition is, how you all learn things. So to the start, how it all started. It basically started with the dream of offline support. And what is that dream? Well, we have the Web App Framework. The Web App Framework has capabilities of providing nice mobile UIs. But as soon as your connection is gone, it doesn't do squat. And that's pretty much because almost every click goes out to the server to ask what should happen. So we wanted offline support in our web apps. And we didn't want you guys all to have to learn JavaScript, because else we would just be yet another JavaScript framework, right? That's not nice. And so our first idea was to come up with a DataFlex script. That's why you'll see Flex script up there, and during the demo you might see Flex script in a couple of places still. So was our first idea, and we were actually thinking of compiling DataFlex code to JavaScript. But then WebAssembly came along, and when we found out about WebAssembly, we immediately thought this is something we can use. This is something we can do things with, and especially with mscripten. Mscripten is a compiler that allows you to compile C code and C++ code to WebAssembly. So basically, that gave us the idea, could we port our runtime to WebAssembly and have it run inside the browser? So you can run DataFlex code inside the browser. But that turned out to be pretty difficult. We had about 40, almost 50 years of technical depth in our runtime, in our framework, and over 20 years of only testing it on Windows. So it turned out that we were using a lot of Windows APIs, and the times that we were just using POSIX C, which is platform independent, have long gone. Yeah, we actually, Bram has been sitting in the basement for a couple of months to actually try and make it work. And we never know how far he got, because every time he fixed an issue, he got, every time an error got fixed, he got 10 new errors. So yeah, we just don't know how far we were. Then we even tried to compile the last non-Windows version to WebAssembly, but pretty soon found out that that wouldn't make sense at all, because then we would have to backport all those features that were added later. And I know that Marco would be happy about that, but it wasn't what we wanted to do. So that's so we decided to build a brand new runtime. So a new runtime that is going to be future-proof and is going to get us through the next 50 years. At least that's the goal, the ambition. We started using modern C++. The current runtime is written in C, not C++, so we took the latest tools. We're doing quality assurance with unit tests, coverage tests. We're using build servers, and we're immediately building it as a multi-platform runtime. Yeah, our only requirement that we made, that we already broke, by the way, a little bit, but was that it was going to be compatible with the existing FLX bytecode. So we are not going to redesign the language. And the main reason for that is, A, because we would have to teach you a new language then, and B, it would make the project a lot larger, because we would have loads of discussions about syntax and what should we do. So that's why we made that choice. So it's actually using the existing compiler. Now that we had this plan, we defined 3 stages. So our first goal was still to go to WebAssembly. So the first version will have a WebAssembly version of the runtime, and that will give us offline support for web apps, and it will give us more responsive UIs on the web. And then you could also wrap that into native apps using technologies like PhoneGap and Cordova. So that's. Then the second stage would be to have web apps, server-side web apps, running on the new runtime. And for that, we want to build a new web app server, and we want to be able to do that on all these different platforms. So we should be able to run web apps on Linux inside a Docker container. That's the plan. And then the third phase was defined as doing desktop applications. And that's the phase that we haven't really thought through yet. That might just become a Flextron container or something. I don't know. We don't really know yet. So then development started. And yeah, the fun began. So we started building a new environment. We set up a build server. We started running. Immediately started testing on all these different platforms. So what you're seeing here is that it actually runs the runtime. It compiles it for FreeBSD, for Linux, for macOS, for Windows, and of course the mscript and WebAssembly version. And then it runs the unit tests on all of these. And yeah, we also did coverage tests, and we use CMake to make this all possible. And also because Bram likes developing in CLion, but that's so. This is an image of the architecture. It's not really accurate anymore. We already made changes, but just to give you an idea what kind of things are in the runtime. So we have instruction loops, argument I/O, we have objects and classes, of course. We have some runtime classes. We have the expression engine. So when you run an expression, that's actually a separate engine. It always has been. So that's, yeah. And, of course, we also needed a debugger. And I'm really surprised with how well this actually turned out. We looked into that. How are we going to debug a WebAssembly application that's running inside a browser? Well, and actually, Chromium has solutions for that. So we're building a debugger that connects to a Chromium browser, which is either Edge or Chrome. And then it connects to it using the DevTools protocol. And that's how we debug our DataFlex application that's running inside the browser. So, does that all make sense? All right. Let's try and do some demos. So we have a special version of the Studio, 99.1, and this is the one that can do FlexScript or text stack. And here I have a workspace DataFlex unit tests. And if I open that, we see that here we have a run all tests.wasm. And in here we have a whole set of unit tests. For example, simple tests for testing string functions in the expression compiler, for example, and expression runtime. So if I now run this application, I'm first going to run it without the debugger, we see that it's really fast. Just before the browser really started rendering, the tests already finished. So here we see that it did run all these tests, and we're lucky we have no failures, so that's good. But what is interesting about this is what it actually loaded from the server. So if we look at the network traffic, which might be a little too small, can I make that bigger? Is that Control Plus? Or? Oh yeah. All right. So of course it started loading the index.html, and if we look at the well, we're going to look at that in a different way. So it loaded the index.html. The index.html loaded the boot script, the JavaScript boot script, and the JavaScript boot script actually loads the wasm runtime. So this thing is the runtime compiled to WebAssembly. Right now it's about 1 megabyte big, and we're trying to keep it that small, or at least try to keep it small. And we have something that came back from the past. We have an FLX file. So we have a run all tests wasm.flx. So this is your compiled DataFlex code. So it has downloaded this, and it has executed all the tests, and it did run them. And yeah, it does all that without going back to the server. All right. Let's see if we can try to run this with the debugger. Yep. What we saw happening now is that it took a little longer to actually start, because the runtime actually has to wait for the browser to start and for all the developer tool stuff to happen, and for the studio connecting to the developer tools protocol. And yeah, so if you have the debugger, want to attach the debugger, the runtime has to wait before it actually starts doing stuff. And now we are in a breakpoint, and we can see locals. If I press F10, we see we can debug our application just like you're used to with the original. We're calling it the classic runtime now. So that's so yeah. So if I press continue, we see that it continues, and the tests also with the debugger enabled do succeed. So that's nice. Yeah, let's get back to the slides. So what we saw here is that we have a runtime written in WebAssembly that is actually already having a lot of features. There's a lot of it in there. The basic language is working. We have, because if we look at the code, that's maybe good to point out, we see we have objects, we have functions, we have expressions, we have a debugger. So it's starting to become fairly complete. So that's what I want to emphasize. And of course, it's just DataFlex code. Some technical details that you're probably all going to forget, but first thing, structs and arrays and BiRef turned out to be very, very complicated. We gained a lot of respect for how Sonny built that into the existing runtime back in the days, and at some point we even considered just taking that code and putting it back in, because of course you can put C code in C++. We also came up with a new concept that's internally in the runtime. You won't notice it, but we have an RT value, which is basically a struct or a class that represents a DataFlex value, variable buffer thing. So we don't have these global buffers anymore, so argument size is not a thing. And the nice thing about that is that we can do ref counting on any heap allocated type. So structs and arrays, if you move them around, it will never make a copy until you actually make a change. And the same thing for strings. If you have a string and you put it in 5 variables, but you don't change it, you only have 1 string in memory, and they're all pointing to the same string. So that's we have a lot less copies, memory copies of structs, arrays, and strings than the original runtime does. We did have to make a new expression compiler. We needed that for the debugger watches to work. That's a funny thing. So yeah, we did have to build a new expression compiler, so we started touching the compiler as well. But this gave us also the chance to do some nice optimizations there and modernize that code quite a bit. The last thing is that the variant type, because we had to re-implement all these types again. We have, the number, the date time, all those things. And the variant in DataFlex was always based on the COM variant, so the Microsoft COM variant. And Microsoft already says it's a Windows thing. And yeah, we don't want to be platform dependent anymore, so we had to come up with something else, and we actually made the variant now really a variant in DataFlex, so it's really its own type, which is very nice. It's a lot faster, and yeah. Of course, you might wonder, can you just run unit tests with it? Well, of course, we can also do more with it. So if I go back to my studio, open this workspace, DataFlex Web UI. What we're seeing here is that we have an application using web controls, and we have a couple of views here, and for example a dashboard, and this also runs. So if I open it, we see that it's running, so it's capable of working with the web controls. And the nice thing is, if I go back to the network tab, that if I move around, it only loads the data, but you can just move around without it communicating to the server. So it all happens in the browser on the client. So it's really running this application on the client. So if I go to myself, for example, we see it does keep on loading the JSON, but that's just because we didn't really optimize this. So that's pretty nice. And yeah, you can even play Tetris with it. It's a lot better now than in web order because it doesn't have to go to the server for each step. It's just happening completely on the client. So it's a lot faster. That's just a little gimmick. All right. So now we have all this. What's next? And then we had a bit of an issue. We had to design how we're going to do data binding, because of course DataFlex is about data. And so far we don't have a database API, we don't have drivers, we didn't hook all that stuff up. And we also don't have data dictionaries yet, because the data dictionaries are built into the runtime, on the classic runtime. And yeah, we didn't port that. So we have to redesign how we are going to talk to the database. And this turned out to be actually quite a difficult project. We start by setting up some requirements. We want to provide data binding and business rules on the client. So if you have that WebAssembly application running on the client, you want to have validations there. If a field is required, it should already validate that. We only want data to go over the line, because in a lot of situations you're going to load data from a server application. So we want only data to go over the line. And we wanted to open up connectivity a bit. We want to give more hooks and chances to get between the data dictionaries and the database driver. So in DataFlex code. And we wanted to optimize it for loading larger sets of data, because as you know, the way the drivers work with finding all the related parents, it can be a bit inefficient at times, and we wanted that to be more efficient and utilize SQL joins, for example, when you're using a SQL database. Another wish we had is to improve the debuggability of the data dictionaries. Right now, the data dictionaries are a bit of a black box, so if you send a request save, it goes in and it comes out somewhere else, and your debug cursor starts to jump around. So yeah, we wanted to improve that, and the easiest way of doing that is, of course, by building it in Flexcode. And another thing we had is file list. File list, of course, would live on the server, and yeah, we really wished to have it on the client as well, but it would be even more inconvenient. So yeah, we don't want file list anymore. And no more global file buffer. And that's just so we don't have to explain to new developers what the difference is between the local buffer and the global buffer. So that's what we came up with as requirements. Of course, we want the main requirement is to preserve the DataFlex DNA and increase flexibility, and of course provide some level of compatibility with your existing code. So we came up with the idea to compile the database model into your application. So we're going to compile the database model in your application so it doesn't have to go out to the server to ask it first. So it knows the structure of your database, it knows the fields, the tables, the types, the lengths, all those things. And we want to use structs as file buffers. And yeah, the main thing is the database API has to become stateless, because you have the situation where you have the internet between your client and your server. So it has to be able to go over the network to go talk to the backend and get the data. And yeah, the plan is to rewrite the data dictionaries in Flex code. So that's, yeah. So this is the idea we have for defining a table. So the idea is to have an entity command, and the entity command is a lot like how you define structs. So you have your fields just as types. Fields have DataFlex types, and then you have metadata like primary key, auto increment, size, and maybe alternative names for the backend. Those kinds of things defined as meta tags. And then you would compile this into your application, so the client knows the data model, the server knows the data model, and it would also define a struct that matches your table structure. So you would automatically be able to transfer file buffers as structs. Are we coming along? Good. All right. But wait. We don't have tech stack on the server yet because that was defined as tech stack 2. And now we're coming up with this entity stuff. And that basically means that we would have to build it into the classic runtime if we want to provide both the server and the client side. And that's not the plan. So what we did is we moved the server-side web apps a little bit forward. And actually, we're doing that with the existing web app server. So yeah, we decided that we wanted to have server-side web apps with the new runtime, but running under the existing server. What that meant was that we had a few pieces missing, and the main thing is the web app server is relying on COM. COM is, of course, a Windows thing, so that's one thing that was missing, and we didn't have a debugger for Windows yet. So that's yeah, we stepped out of the data binding a little bit, and we implemented that, and Bram came up with a nice way of having an independent interop layer in the runtime, so a generic way of talking to external interfaces, and then based on that for Windows, you could easily build the COM support. And this would also be the basis for, in the future, writing DLLs in DataFlex code, for example. And what I really liked about this as well is that this proved that with the new runtime, the new code structure, we can more easily implement features like this. So that's good. All right. A little demo. So here we have client UI sample, and we also have server UI sample. And when I compile this, that's probably going to say me that it doesn't have to compile, but this generates an FLX as well. And then in the web application administrator, here, I had to configure this application a little different. So instead of putting your webapp.exe as the file name, as the application to start up, I made it start up the Windows version of the runtime. So we have df-vm.exe, and we also had to tell it which FLX to load. So this is the path to the server UI sample FLX. And this actually works. And yeah, it's also maybe nice to mention is that in the server UI sample, we have a C web server app, and the client UI sample, which now doesn't render anymore, has a C web client app. So that's, I found that nice. So if I open this, we see the same application pretty much because I reused the same sample, but now for every click, it has to go out to the server and make the well-known calls to call action. Oh yeah, that was the button I shouldn't click because it didn't work. But yeah, so that functions as well. So we now can also run web apps on the server. Of course, we would also like to debug them, and that meant that we had to write the Windows debugger a little earlier than anticipated. So if I go back to the unit test workspace, I have a run all tests that doesn't use the web version of the DF unit application, but the Windows version. And I now run it as 64-bit tech stack. And if I run this, we see that it hits the breakpoint, and it's now running the same unit test on Windows. And you can actually step through the code. So you see the values, and it's so we have that too. All right. So that was a little sidestep. Back to data binding. So and this is where it gets, where we're getting further away from what we already have. Now we're really going to start looking at concepts that we didn't fully implement yet. And yeah, so a lot is open for change. But our idea is that we're going to make a DataFlex database protocol, which is going to consist of a message format with requests and responses. And there's going to be a system of what we are going to call probably data adapters, although we're open for different names. Might also just become drivers or something. Data adapters that can forward these messages, can manipulate them. They might serialize them, send them over a network, or they might go to a database and do the actual operation. The data adapters, they will first be written in Flex code, but we might end up optimizing by providing built-in data adapters in the runtime for performance reasons, but yeah, we'll see if that's going to be necessary. The data will be passed along in structs and arrays, so if you're getting a set of data, you will get an array of structs, or maybe a multidimensional array, depends on the call, and a find will give the data back in structs. So yeah, it will support the basic CRUD operations, where of course read in DataFlex is find, as you all know it. And we're planning to add, but we didn't implement any of that yet, so that's going to be new, a query API that's going to read a set of data with fields from multiple tables in one go. So yeah, these messages are going to contain table IDs or entity IDs. We're not really sure yet if we're going to, how far we're going to use the entity name, or if we're also going to start talking about tables at certain levels. So it's, yeah, that's all stuff that has to be figured out. But a read and a find, for example, will, of course, tell it which tables it needs to load. So it's not just a single table ID, it's going to be multiple table IDs. It's going to tell the relations, the constraints, the index field values, the direction, maybe calculated fields, and then that's going into the data adapter, and the data adapter is going to come back with the data. So we'll have different types of data adapters, for example, HTTP adapters, cache adapters that might go out to local storage and use cached data, and of course database drivers. So that's, yeah. So for example, if a web list is going to fill itself, it's going to do a query call. It's going to say, I need these columns, give me 80 records, figure out the relations yourself. It's going to tell that to the data dictionary. The data dictionary is going to say it to the data adapter, and then the data adapter might decide to send an HTTP request to the server, where a data service will handle that. We'll go back to the data dictionaries for validation, of course, and then it might go out to the database. So that's the idea. All right. Yeah. So now we're going to look at a prototype, and this is really prototypal code. This is pretty far from what's going to be production, but I want to show it anyway to give you guys an idea. of some of the things we're thinking of. And yeah, it's going to have these entities. It's going to have a new API that we built into the runtime, which is reflection on structs. So you can now access struct members by index. And yeah, it's going to have a Flex database driver, which we, yeah, for now wrote with SQLite because we had that DLL and package floating around anyway. Which also shows that we have external function implemented. So if I go to DB tests, and this is going to, we're going to run this on Windows because we don't have the SQLite on the WebAssembly side yet. And yeah, this has multiple tests. And if we go to single table, we're seeing that we're defining an entity. We're setting it as primary key, auto increment. We're doing stuff. And then we're creating a data dictionary. So there will still be data dictionaries as you know it. And we're binding the data dictionary to that entity. So we're telling the data dictionary which entity is it should use. Like main table, yes. And if we look at the data dictionary class, we see that it inherits from C entity, which is basically the runtime class that's going to give us back all the metadata that's compiled into your application. So that's all right. So here we have a SQLite adapter object, and we have a customer data dictionary instance. We're telling it to talk to the SQLite adapter. And then the first test is about creating the database. Because we have the structure now compiled into the application, a driver can real easily use that structure to actually initialize the database, to create it. And here we have a test where we're going to actually work with it. So if I run this, we're seeing that this test actually runs. And it also succeeds. So if I press F10, it should go down. And we see that actually field current value and things like that actually work. So this is basically the test for the field buffers. But we also have a test where we're actually going to save records. So this is code that you might recognize. Send clear and then set field changed value and then a request save. And that actually will actually work. So if I run the entire test, what we're going to see is a lot of debug code. It's shooting the queries that it's generating and all that stuff. But yeah. So if we scroll down here, we also see something interesting. We're thinking of making the old find commands work with the data dictionary objects. So what we can say here is find gt o customer dd.city. And that's going to do a find greater than on the o customer data dictionary. And basically that command is going to translate into a message. So it's actually pretty funny if you run it and you step into it, which doesn't always work. Hopefully it works today, yes. We see that we're ending up at the o customer dd object, and it's just sending the find by field. And we might as well step through it. We're seeing that it's filling some structs. So this is what we have now for the message format. So it's filling some structs with actually down here it's going to put in index data. It's going to figure out which parents need to be included. And here it gets interesting. Here it's going to call send process message of HO adapter. So it's basically this is how it's going to fire the request. And what's the most interesting to see, which hopefully, if I F10 long enough, we see that it actually came back with a struct T customer with the data. So it's using structs internally to move the data around. And since the new runtime is so much more efficient with structs, what's actually happening is that the driver fills the struct, and then the struct is passed back by reference, so it never has to copy the table buffers in memory. It always keeps just a pointer, and that's going back to the data dictionary, which is then going to seed its buffers with it, and is going to set found to true, and that's pretty much what it's doing. Now the debugger is going to act a little funny, so I'm going to stop it. And of course, we also have another one, database relations. So here we have two data dictionaries, and we're defining the relation. That's one of the things we're not sure about. Probably the relation needs to go to the entity definition as well, so that's the kind of things we're still wondering about, but we're trying to make stuff work first. This is really prototyping, so trying stuff, seeing how it feels. And yeah, this test will actually find it's going to create data. If I put it here, find both records. First need to clear those. Yeah, all right. I'm pushing it. Need to restart. Do we have more breakpoints? Yes, all right. So the last thing I wanted to show is that this find by field actually generates a single statement. Did it do it already? Select with a left join in it. So that's basically the idea that I wanted to show, that it's actually a find message is automatically able to do a relay, so it can automatically give back the parents. So the message is going to say, hey, give me this record and these parents with it. And that, yeah, that's pretty much it. So this was pretty much a sneak preview in our little play garden, where we're trying stuff and figuring out how stuff has to work. So yeah, let's get back to planning. Well, we're working really hard on the data binding stuff, but yeah, we have the other stuff to finish as well. So yeah, the plan is now to have for Tech Stack 1, have a WebAssembly runtime for client-side apps and a matching server-side web app with the new runtime. And yeah, the new data binding in it. And then later on, we'll come up with a new web app server that allows you to run web apps on different platforms as well. So that's the current plan. When is, of course, the big question. Yeah, the answer is we really don't know. Yeah, so yeah, we're going to stick with December then. Good suggestion. That's well, like Bram already explained, we're going to link it to the package manager, because we believe the package manager is going to be really important in releasing this, because when we put out the first version, we want to be able to respond quickly to bugs. So we want to be able to push updates like weekly or monthly or daily, and add the missing features. And yeah, we're really working towards that technology preview, but we did make the decision that we're not doing a technology preview without the data binding. So we want to have the data binding to a level where it's really usable. So that's it for me. Are there any questions?
Come back to the Q&A session. I hope you enjoyed the presentation of Harm at the EDUC. And there were some questions, I believe. So let's immediately dive into the questions. Dennis, what is the first one?
Okay, from Mark.
Mark.
Wizards for create struct / entity from DB table and things like that, right?
Harm?
Yes, certainly. Yes, there will be wizards to create the entities. It will be a lot like you maintain the tables right now. Well, we haven't built that yet, but it's but it will be there. And the thing we already have is we already have code for converting tables into entities, so to generate entities based on an existing database model. So that's actually, right now we have unit tests running with the, of course, famous order entry model, but that we generated using a little script, and there will definitely be, wizards around that and conversion things. So, yes.
Nice. More questions.
Okay. From Stura, when defining tables as structs, can you also specify indices indexes on the table?
Yes, you can.
Yes, you can.
First, yes, the answer is yes. Yeah, so not only will we have the members, we will have the indexes and also the relationships. We're still seeing how that completely interacts, but at the moment that is the current state where we define both.
Right now it's like a command, isn't it? There is like an
we have an add relation and a add index.
Yeah, and that's also stored as metadata, and then the drivers and the data dictionaries can actually query that, and the data dictionaries will also query the relations and use that like as a default. So when you set up your DDO structure, you can have local relations, and you can have it will also look at the relations defined at entity level, and the other things will mainly be in attributes, but the indexes and the relations are the ones that are not attributes but are commands.
Yeah.
And can we have meta tags on indexes then again? Not sure.
I am not sure.
Yeah. I don't remember either.
Good question, Harm.
All right.
Yes.
We'll see. All right.
More questions.
Okay. Will we still be able to use table name .column name symbols when referencing table columns in the source code?
Yes. So what we attempt to do is be as backwards compatible as possible. And one of the nice things, of course, is the entry item, for example, and also the move semantics. So that's one thing that we wanted to keep. The only difference now is that the table name is now replaced with essentially the data dictionary object name. So what will happen, instead of move customer.name to s-value or anything like that, you'll now do move customer dd to s-value or anything like that. And the same goes for the entry item as well. So when you attempt to link a user interface control to a data dictionary, you also use the entry item with the customer dd.name.
Yes, and the find commands also redirect to the data dictionaries. And the nice thing is we abandoned the global buffers.
Yeah.
So the data dictionaries talk directly to the database API, but you can actually mimic the global buffers by having a singleton instance of a data dictionary somewhere. So having a global DDO structure somewhere. And then that will act as, you can use that as global buffers and still have, the differentiation in not changing the current record of your local DD.
Okay. Are there more questions?
Yeah. What will be the replacement for properties data_file and data_field? Anything that gives a hint as to what our code will look like when the access our database is interesting.
Oh.
Yeah. Well, in the current implementation, those properties actually still exist. The only difference is, instead of having the table number, they now have an object handle in there. And that's actually, in a lot of cases, the table number is replaced by an object handle.
So the developer doesn't really notice, because you normally also didn't touch the
in a lot of cases, it will actually be usable the same way as when you had a file number there. So it's there, but it's going to be an object handle. One thing to notice is that it would be nice to actually, whenever you're referring to it, to replace your usage of integer with handle. Well, of course,
it works, but it is for future.
Yeah, for the future, it would be better to use handle, because that's the type that is created for it. And all right. So I think that answers it, doesn't it?
I think so. I think so. Yeah.
Yeah.
Dennis, are there
the
more?
last question is the data dictionary API is very verbose. How does that work?
Verbose as in huge? Or that's well, the thing with that is, we are rebuilding the data dictionaries, and we are rebuilding them now in DataFlex code. So it's going to be a completely new implementation, and that also means that the first version will not have all the features of the old one. And we are planning on having a bridge subclass layer where that basically translates, message names that we might change because we want to modernize things a little bit as well to the old syntax, so you can still use the old names. But in the beginning, it will probably be more limited, and it will not have all the features of the existing data dictionaries. And yeah, that's also one of the reasons why we are focusing the WebAssembly platform, because that's a new platform. So yeah, we want you guys to build new apps for that. And that's where we're getting started with the technology stack, and then later we will focus more on replacing it, the existing runtime on other platforms, and then compatibility becomes probably more important. But yeah, it's inevitable that there will be compatibility issues, especially with things like the data dictionaries and the database API, because we are rebuilding it. So at service level, there is we thought about compatibility, and there will be a lot of compatibility, but there will also be a lot of incompatibility. So that's it.
Okay, nice. Oh, was that the last question, or is there more?
That was it, yes.
That was it. Okay, perfect. Then I think that wraps up this live stream. Dennis, I would like to ask you to conclude the rest of the live stream.
All right. Thank you again, everybody, for watching. And I want to remind you that the live stream is accessible at any time if you revisit the same URL here on YouTube. And all of the Q&A answers will be posted on DataFlex.dev, our new website.
Yeah, that's it. Okay,
All right.
thanks, everyone.
All right.
Thanks.
Thank you.
See you.